Events.
Seriously, think about it. What if you were getting thousands of pizza orders every single minute? How in the world would you design a kitchen to handle that kind of volume without everything just grinding to a halt? Well, that's the exact problem NGINX was built to solve, and its approach is nothing short of genius. All right, first things first, we need a crew. In the NGINX world, this is its architecture. And the whole philosophy is about having a small, super elite team that can run circles around a massive, clumsy army of workers. This is probably the biggest decision we have to make for our shop. Do we hire 10 chefs, 50, 100? I mean, if you hire too many, they're just going to be bumping into each other, getting in the way, and slowing the whole operation down. We've got to find that perfect number. And this is where the NGINX philosophy just shines. With the worker processes directive set to auto, NGINX is like the smartest manager you've ever had. It takes one look at your server's kitchen, counts the number of CPU cores, think of them like burners on a stove, and hires exactly one super efficient chef for each one. No more, no less. It's the perfect balance for maximum output right out of the box. Okay, so we've got our elite crew, but these are not your average chefs. No way. These folks are masters of multitasking. So the next logical question is, just how much can we throw at them at once before they start to crack? And the answer is, frankly, staggering. The Worker Connections Directive tells each chef they can handle, in this example, 4,096 orders at the same time. Imagine a massive wall with 4,096 order tickets that they can manage all at once. So you do the math. If you have just 4 chefs, your shop can handle over 16,000 connections simultaneously. It's incredible. So you're probably thinking, okay, hold on, how is that even possible, right? How can one person manage thousands of things at once without getting totally lost and slowing to a crawl? Well, this is where we get to the secret ingredient in the NGINX recipe. It's all because of this little directive, use EPAL. See, instead of our chef constantly running around the dining room asking every single customer, "Are you ready yet? How about now? Are you ready?" They've got this magic intercom system. The operating system only buzzes the chef when a customer actually needs something, like their payment just went through or their order is ready to be taken. This event-driven model means no wasted time, and it's the core secret to NGINX's legendary speed. Okay, now for a little twist. A lot of the time, our NGIX pizza shop doesn't actually make the pizzas itself. Instead, it acts as the super friendly, super efficient face at the front counter. It takes your order and then passes it along to specialized kitchens in the back. This is the art of the reverse proxy.
Proxy. Pass.
And this is the main instruction for our front counter staff. The proxy pass directive is super simple. It just says, when a customer comes in and orders something, our front counter doesn't make it. Instead, it immediately passes that order straight back to the real kitchen, which is running at this other address, our backend.
Proxy set header.
Now, there's a tiny little problem with this setup. When the order ticket gets to the back-end kitchen, it looks like it came from our front counter, from NGINX, not from the actual customer. And that's not great for keeping track of things. So this proxy set header line is like adding a little sticky note to the order that says, hey, by the way, the person who really ordered this is at this address. This is absolutely critical for things like logging and security. All right, let's wade into a huge debate in the pizza delivery world. when the kitchen finishes a pizza, what's the better strategy? Should we send out each slice the second it's cut, or should we wait for the whole pie to be boxed up? This gets right to the heart of a concept called proxy buffering. And this really shows you the trade-off. By default, NGINX has buffering turned on. It waits for the back-end kitchen to finish making the entire pizza. It puts that whole pie into a thermal bag, which is really just a memory buffer, and then it immediately tells the kitchen, "You're free, go make the next one." This frees up your expensive back-end resources super fast. But if you turn buffering off, NGINX sends each slice the moment it's ready. The customer starts getting their food sooner, which is great for things like live video streaming, but it keeps that back-end kitchen tied up for a whole lot longer. So to manage all this, we configure our thermal bags. Proxy buffer size is for that initial small order note. And proxy buffers defines the main bags for the pizza itself. The key here is making sure your bags are big enough for your average pizza. Because if they're not, NGINX has to spill the order onto a temporary file on a slow disk. And let's be honest, nobody wants a slow, cold pizza. Of course, any great pizza shop has to be a secure one. We need to make absolutely sure that every order and every payment is private and totally protected. In the web world, this means locking the doors with SSL and TLS to enable secure HTTPS connections. Setting up security in NGINX is basically a four-step process, like locking up the shop at night. First, we open the secure encrypted door on port 443. Second, when a customer shows up, we show them our public business license, that's the SSL certificate, to prove we are who we say we are. Third, we use our own secret private key to read their encrypted messages. And finally, we both agree to only speak in a modern, unbreakable secret code, like TLS 1.2 or 1.3, and refuse to use any old insecure languages. Now, beyond just being a great front counter, one of NGINX's true superpowers is acting as a lightning-fast file cabinet. It's amazing at delivering things like images, menus, or even videos directly to the customer. And the secret to this incredible speed is the send file directive. Think of it like an express delivery lane in the warehouse. Normally, sending a file means copying it from the storage shelf to the front counter, and then from the counter to the delivery driver. Send file basically builds a direct conveyor belt from the shelf straight to the driver, skipping the middleman entirely. It's such a simple switch, but it makes file delivery unbelievably fast. NGINX also has this really clever shipping strategy. For big shipments, it'll wait until a delivery box is completely full before sending it out. That's maximum efficiency. But for small, urgent messages, it'll send them out right away, even if the box is mostly empty. By using both of these strategies together, NGINX intelligently optimizes every single delivery for either efficiency or low latency speed. It's pretty smart. And this is a huge deal for modern media. With the MP4 module, if a customer wants to watch one of our promo videos, NGINX doesn't make them download the whole thing first. It lets them stream it, which means they can start watching instantly or even skip to their favorite part, because NGINX is only sending the specific piece of the video file they're asking for right at that moment. So let's recap. What's the secret recipe for our NGINX pizza shop? Well, it's a small, event-driven crew that can handle a massive amount of traffic. It's smart order routing that lets it act as the perfect middleman. It's an efficient packaging system that frees up your important back-end kitchen as fast as possible. And it's an express delivery lane that serves up files at lightning speed. You see, when you start thinking about web traffic like it's just a bunch of pizza orders, all these complex technical directives suddenly become simple, intuitive business decisions. So the only real question left is, Now that you've got the recipe for speed and efficiency, what amazing things are you going to build in your kitchen?